Hello, I'm Maggie Boyajin, and I will be talking about the narwhal today. The narwhal species is part of the Monodontidae family alongside the beluga whale. These two are toothed whales that are known for their ability to use echolocation as a tool in hunting and navigation. The narwhal can also be identified by the very distinct tusk that comes out of what looks like is its forehead, that all males and some females on rare occasion do have. And all that it really is just a very elongated left canine. They can be found year-round in mainly the Arctic waters, in and around Russia, Greenland, Norway, and Canada. Narwhals vary in size around 3.95 meters to 5.5 meters and can weigh in between 800 kilograms to 1,600 kilograms. So considering most whales, narwhals are on the smaller side. Some of their diet includes halibut, Arctic and polar cod, squid, and shrimp. And unfortunately, narwhals do face a lot of danger because of oil and gas companies that are a constant threat to the species as climate change becomes a worse issue, having very deadly consequences, especially in the Arctic areas where narwhals reside. Now to talk about vestigial structures, mainly their teeth, the narwhal is described as a monophyodont and homodont, which means they have one set of teeth throughout their lifetime. And at a young age, narwhals have 6 pair of tooth buds, 2 in the maxilla and 4 in the mandible. And one of these pairs in the maxilla, well, one of the pairs in the thing grows to be the tusk. And the other one usually doesn't grow. It's very rare for a narwhal to have 2 tusks, but it does happen. The other pair is just vestigial teeth that have no real function. Narwhals take up a lot of their tooth energy and use it to grow that one tusk when they could use it to grow up to 40 teeth. The mechanism to grow this asymmetrical tooth is still not fully explained by the mechanisms of evolution, but there is hypotheses that the tusk serves a special function. That's why they do use all this energy to grow it. Now to talk about adaptation and variation. Unlike most aquatic organisms, like you might see in sharks, the narwhal does not have a dorsal fin, which could be an adaptation to make them better swimmers under thick ice, which is usually what the Arctic is made of, and it helps them to facilitate rolling under the ice. Narwhals also have a great neck flexibility because their neck vertebrae are jointed, which is a similar trait to many land mammals. This is a crucial adaptation that allows them to easily move their heads around without turning their body in order to be able to use their very long tusks. And narwhals have a very low genetic diversity, which can cause problems for the future generations because they are less likely to adapt to changing environments. However, they seem to be doing fine for now, but many scientists believe that this is yet to be tested because of climate change and the new threats facing the Arctic. Natural selection. The tusk of the narwhal plays an important role in its evolutionary history, especially when looking at its role in natural selection. The tusk, as mentioned before, is just a modified tooth that is projected through the upper jaw. The energy used to grow that tooth can be argued was well spent. Some of the functions of the tusk include self-defense and being able to break the thick ice when they're swimming underneath so that they can breathe. And recent studies have showed that the tusk has nerves that lead straight to the brain. And this suggests that it also functions as a sensory organ. And overall, the tusk is a very favorable trait in the narwhal population, especially among the males. And now to look at the fossil record, the original theory of the evolution of cetaceans said that whales are related to mesonychids, which are carnivorous hoofed animals, and similarities in the unusual triangular teeth were found in both, which was where this theory came from. But recent data shows that narwhals are most closely related to artiodactyls, which are most specifically the hippopotamus. The only problem is early ancestors of hippos don't appear in the fossil record until millions of years after Pachycetus. And you can see the evolutionary tree in the top right picture, which shows the beluga and the narwhal being most closely related and their common ancestors. The first known whale ancestor is the Pachycetus. Discovery of skeletons from the Pachycetus family confirms that whales descended from the artiodactyls and not the mesonocids, which was the previous theory. And they also know that artiodactyls took to water soon after the split from the mesonocids, which would lead to the narwhals. There's a lot of recent work still going on right now studying the evolutionary history of narwhals. There's a lot of unknowns, mainly because there's not a lot of species and it's hard to connect a lot of the evidence that they have been collecting. But to look at three of these studies, the first one by Samuel Ellis looks at the reproductive lifespan of narwhal females. And the reproductive lifespan has evolved several times independently in the toothed whales like the narwhal. This work is being done, like I said, by Samuel Ellis and colleagues at the Center for Research in Animal Behavior at the University of Exeter. And through extensive research and going through published works, they were able to quantify the rate of reproductive deterioration in the female toothed whales. In the second article, Zachary A. Graham and colleagues at Arizona State University used morphology data collected from narwhals in Greenland from 1983 to 2018 to study the function of the tusk and determine whether there was sexual selection in play. Based on the large variation in tusk length and the disproportional growth, they determined that the tusks are indeed sexually selected, which they suggested was used during male-on-male contests to try to attract females. And for the third article, as climate change is proving to have devastating results on the Arctic, Marie-Louise and colleagues aim to understand how species respond to the climate oscillations from the past to help them predict how the same species could respond in future events. Narwhals are unfortunately one of the most vulnerable to climate change. The glacial conditions have contributed to population size expansion of many predators, which is concerning for narwhals. The low genetic diversity of narwhals is also very dangerous as climate change, because there's a higher chance of many individuals not being able to survive and reproduce, and basically stopping the evolution of these narwhals. The lower the genetic diversity means the lower the chances are of them having the most favorable trait that will be useful in these types of situations. And that is all from me. Thank you for watching.